Today we're going to draw the octet rule exceptions for nitrogen monoxide and nitrogen dioxide. They are both odd electron species. As you can see here, I've added their valence electrons from nitrogen and oxygen to get 11 electrons. So I like to make a note to myself that these are going to be odd electron species so that when I draw, I don't accidentally add an extra electron, which I've done twice, once on an exam and once on a practice exam. Very unnecessary mistakes, and these are definitely questions they're going to ask on your final exam. Okay, now we're going to add 11 electrons here, and I like to count one by one for odd electron species so that I don't accidentally tempt myself to add the 12th electron. Okay, so we have 2 electrons here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is only just going to be 1 electron on top of nitrogen. But for any Lewis dot diagrams, we have to ask ourselves, is the octet rule met? And here, no, we still need something here. So we're going to pull a lone pair from oxygen to make a double bond. And then we check the octets for everything. It is good. Now we ask ourselves the formal charges. So nitrogen has 5 valence electrons, and here we have 3 electrons just ramping around, and then we have shared bonding electrons, so half of it is going to belong to nitrogen, or what I just like to say is 5 minus number of electrons plus number of lines, so 5 minus 5, so that's going to be 0. Now for oxygen, it has 6 valence electrons minus 4, and then 5, 6. So this is going to be 0 formal charge, so this will be our Lewis dot diagram. Notice how nitrogen monoxide has a lone electron and it has a double bond. So when you're on your exam, make sure your drawing is reflecting both of those strange elements. Okay, nitrogen dioxide, 12 valence electrons from oxygen, 5 from nitrogen, and we can see again that this is an odd electron species. So we got 4 electrons here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's an odd electron species. Now the octet rule, well, we still need something here for nitrogen, so we're going to make a double bond by pulling away a lone pair of the oxygen. But I chose the left oxygen. That means I could have also picked a right oxygen, which means there is a resonance structure. By the way, the geometry for nitrogen dioxide is bent. Okay, and now we can check octet rule. Good. Now formal charges. 4, 5, 6. The other oxygen has 6 valence electrons minus 6 electrons plus 1 more electron, the shared bond. That's going to be -1. Nitrogen has 5 electrons minus 1, 2, 3, 4. So nitrogen has +1 formal charge. And that is how you get the Lewis dot structures for these 2 octet rule exceptions.